We'll start off today's discussion with a brief overview of SFC. We'll then move into Shimadzu's Analytical SFC innovations, Shimadzu's Preparative SFC innovations, and then we'll show you some applications where all these innovations are put together in a practical format. So let's review a little bit about SFC. I always like to start off by saying it's still chromatography. People have this impression that SFC is some sort of exotic or overly complicated process, but really what it is just LC, where we've replaced the hexane or heptane with a supercritical CO2. It still uses the same polar modifier, additives, gradients, and isocratic runs are possible. It uses the same packed columns, same detectors. But where it differs is we have a higher diffusion coefficient, so SFC can run greater than 3 to 5 times faster than HPLC. It also has lower viscosity, which means we can push samples a little bit harder through smaller particle sizes or longer columns to get additional resolution without paying the price of added back pressure. And SFC is orthogonal to reverse-phase HPLC in that hydrophobicity is not necessarily the primary driver of separations. So SFC is attractive to many people because it's a greener technology in many aspects. First of all, it has a smaller carbon footprint. It uses less petroleum-based solvents. That means it has a environmental impact on not only the generation, but the disposal of those solvents. From a safety aspect, there's less exposure to the end user. There's no risk of flammability, and storage of flammable solvents becomes a non-issue. Then there's also the economical aspects of SFC. So what do we mean when we're talking about greening economically? Well, here's an example of USP method using cortisone acetate. We took the USP method and directly transferred it over using the same size column to an SFC technique. You'll notice that it went 2.4 times faster and at 14 times less cost. We then optimized the separation using a smaller particle high-speed column to get it to go 13.7 times faster at 38.4 times less cost. So it's faster, less expensive, and that is definitely green. SFC has always been associated with chiral separations, but as this pictogram shows from Dr. Baba's group, that over the last few years, more publications have come out with achiral compounds, larger molecules, and different applications. So it's a growing technique because of the greenness, because of the efficiency of the systems, and because of the robustness of the instrumentation. So at this point in the talk, I'd like to introduce you to our Nexera line of SFC solutions. Starting from the left and going to the right, show a very simple single-column analytical SFC system. We have multi-column scouting systems. We also have analytical systems with fraction collection capabilities, preparative systems with fraction collection, and stack fractionation collection capabilities. We're going to talk about more of these in a minute individually and some of the innovations that we've come up with that make them best in class. So let's start with analytical SFC innovations. So in this slide, I'm showing a picture and a flow diagram of a very simple SFC system. If it looks like an LC, it's because it is very similar to an LC with two major differences. One, we're using a CO2 pump as opposed to a hexane or heptane pump. And we're also using a BPR, back pressure regulator. And this is where our first innovation comes in. So our patented high sensitivity BPR offers both coarse and fine control. The fine control is dictated by a piezoelectric fine control system. This allows for a very stable, flat baseline. It also allows us to control the back pressure regulation such that you can enhance resolution. Another Shimadzu innovation that we have on our analytical SFC systems are the ability to incorporate custom blending. By adding additional LPGE valves, we can actually pre-mix modifiers and additives. This eliminates user error, eliminates the need for pre-mixing, eliminates the need for storing of these samples. It should also be noted that this is available on all our analytical systems, LC and SFC. So here's a flow diagram of a multi-column SFC screening system where we've incorporated the LPGE valves into the B pump for the modifiers. This goes into then 2 different column ovens with up to 12 columns and gives you the ability to run a lot of different parameters in one simple run. So what happens if you need the capabilities of an HPLC and an SFC but maybe don't have the budget for both? Well, you can buy a simple system that does both in our LC SFC switching system. So here's a picture of the flow diagram, very similar to the one I just shown. However, we've now added a C pump for the LC capabilities. We still have our sets of LPGE valves, giving us the custom blending features that we had in the previous scouting system, but now we have an additional valve that separates out the HPLC and SFC columns. So if your screening paradigm needs more than 4 options, we have the solution for that. So again, we can add more LPG mixing valves onto the system to upgrade it up to 7 different options. One thing that we haven't talked about yet is detectors. In SFC, all the detector options that you would typically see for LC are available. So we do offer UV, PDA, and ELSD. Shimadzu also offers a complete line of mass spec detection options. I will highlight here the new LCMS 2050, which is a single quad. Note that it is small and very stackable. You can add in triple quads and scoot up as well. There is an advantage to running SFC with mass spec that you don't get over traditional HPLC. In our splitless design, we can actually put the mass spec post-BPR. This gives a marked increase in sensitivity. Shimadzu is also the only company that has an analytical fraction configuration for its SFC systems. This is based on our patented microlotus GLS, which I'll talk about more in depth in a few slides, but it allows us to collect some very small volumes into 96 well plate format without any kind of splash or cross-contamination. So I've talked a bit about the hardware aspects of the instrumentation. Let's move into some of the software innovations. It all starts with Lab Solutions, which is our single platform software for all our instrumentation. It allows for easy walk-up access for multiple users and multiple environments. It's supported by all our models, including all sorts of LC-MS detectors. It has flexible configuration options. It's easy to use, and the best thing about it is once you've learned it, it works for any of our systems. Let's talk a little bit about our method scouting software. It's an automated screening software that is usable on not only SFC, but LC and our LC SFC switching systems. You simply click the columns and mobile phases that you're looking for, it configures it, generates a batch, automatically loads it, and allows it to run automatically. It can be used for gradient and isocratic runs. Our latest software innovation is Lab Solutions MD, MD standing for Method Development. It's an analytical quality by design software program. Now, this can be a whole webinar on it to itself, but I want to give you a brief overview of what it does. So basically, it starts with our screening phase, where, like we saw in the previous slide, it will go through and automatically populate a batch, run it, and give you a base idea of which column and which mobile phase pairings are good to start with. It then uses an optimization phase, which goes through some logic taking the data that was generated with the screening phase and proposes an option for the best solution, the best resolution. As you'll note here, it generates a heat map. You can click onto the area of that heat map, and that will give you a simulated LC run or SFC run. You then can go into a robustness phase, where in this case, for validation, you may need to validate robustness. So we'll go through and we'll toggle around the different parameters just slightly to see how it varies the chromatogram. So one of the unique features about MD is that it also has peak tracking, so it takes the UV trace of each compound and tracks it along. There are cases where, especially in chiral, you may see a change in your mobile phase conditions could actually change the order of evolution. So this keeps track of it so that you're not missing peaks or misinterpreting peaks. Down below, I show heat maps for both the optimization and the robustness. You'll notice that the simulated chromatogram pairs up almost identically to the actual chromatogram in both cases. So we've talked a little bit about analytical SFC. Let's talk about preparative SFC. So you may or may not be aware, but our story in PrEP started with the Enabling Technologies Consortium, which was a group of pharmaceutical scientists that basically said, we'd like an optimal next generation preparative system. And here's a lot of different things that we want incorporated into a system, and we need outside help. So we entered into this agreement with the ETC, and in 2 years, we went from concept to production commercialization of our Nexera PrEP system. So part of the ETC requirement was that we develop a system that has the ability to do stack fraction collection, multiple fraction collection, and easy-to-use software. As shown here on the top left is our stack fraction configuration, the bottom left our multi-fraction collection, and of course our PrEP solutions, which is an integrated software into our lab solutions platform. Another requirement the ETC had was a compressed or compact design. So we actually were able to remove the outside chiller from most of the conventional preparative SFC systems and replace it by a compressor type cooling system, which reduces the footprint by over 40%. One of the more unique innovations that Shimadzu came up with for the preparative system was the design of the loaded stream and micro loaded stream GLS, gas liquid separator. Traditionally, companies use a cyclonic GLS design. These are fairly problematic in that they suffer from splash out, which leads to cross-contamination and ultimately lower yields. Our GLS uses an effect called the Quanta effect that allows the CO2 to move to the side while allowing the sample to drop down into the middle with a very controlled stream. So how good is the loaded stream GLS? In this example of purification of limonene, the first experiment had a 92.3% recovery. And the second experiment, over 95% recovery. Both were in analysis greater than 99%. In the newest innovation on our preparative system, we've now incorporated a larger injection volume of up to 20 mils for a single sample. This was based on customer requests and again shows you that Shimadzu is willing to listen to customers and design systems that really fit your needs. And just a quick slide about our PrEP Solutions software, which again is based on our Lab Solutions platform. Very easy to use, simple graphic interfaces, has on-the-fly method editing so you can do it in real time. The ability to collect stacked injections and actually a program that shows you what the stacked injections would look like on multiple runs. Point and click fraction collection settings. You can direct fraction position, direct waste collection or waste diversion, and you can use multiple detectors, including mass spec, collecting on UV, mass spec, or both. So we've talked about a lot of innovations both in hardware and software, but what we haven't talked about is how you put them all together and put it into a workflow. So let's look at some applications and show how these are all working together to optimize your time. So the first application I've shown here is an enantiomeric separation of the two isomers of linalool. Again, SFC and chiral resolution have been known for years and well associated together. In this case, we use our method scouting software along with the LGPE valves to generate a batch of multiple variants in different run conditions, and we're able to get very good resolution in less than 5 minutes. It should be noted that this is unoptimized. If we went to a smaller particle size or smaller column, we could actually clip this runtime down significantly. In this second application, I'm showing the analysis of glucosyl ceramide. Again, using SFC, in this case with ELSD as a detector. You can see the very good resolution and detection. We always get questions, does Shimadzu make an ELSD? Yes, we do, and it works very well with SFC. In this application, we show the optimization of an analytical method and then scale up to preparative separation. So we've taken 5 compounds that are achiral, and we've run them through our method scouting software using our ShimPack columns and a number of different solvents. In this case, a method was optimized and then taken over to the scale-up process. Taking that analytical method, then uploading it into prep solutions, we were able to do 3 different injections of 1 milligram, 10 milligrams, and 250 milligrams, isolating each component in very high recovery and very high purity. So up to this point, all the examples I've shown have really focused on small molecules. But one of the areas that SFC is starting to expand in is larger molecules, peptides and oligonucleotides. So I wanted to show a couple examples. First is the separation of a 4-component peptide mix. These peptides range anywhere from 6 to 16 mer. We used our method scouting software to screen a number of different solvent mixtures and columns and came up with a reasonable resolution and a column that worked very well. However, it really hadn't been optimized. So here we've taken the same 4-component peptide mixture and rerun the screen using our Lab Solutions method development software. We use the same solvent system and the optimized column from the run before. In this case, the optimization program used central values and varied oven temperature and the gradient. You'll note the top diagram shows the simulated chromatogram and the bottom shows the actual chromatogram, and they have very good similarities. The last application I'd like to show is actually a literature article from the Journal of Chromatography A. Our colleagues in Japan did a proof of concept study where they showed SFC could be used for oligonucleotide analysis. The authors did many examples with both ion pairing agents and without ion pairing agents. I would invite you to look at this article and read it for yourself. It's a great paper. So to conclude today's talk, I'd just like to summarize a few key points. First of all, SFC is an incredibly robust and reliable technique. It's just as easy to use as HPLC, and it has a lot of green qualities to it. It's green in that it has less of a carbon footprint, it's green in that it's safer to use, and it's green in that it's faster to use and can save you money. Shimadzu is the leader in innovative SFC technologies. We provide solutions for analytical to preparative needs. Our innovations, like the BPR, the back pressure regulator, the custom blending that allows you to not have to pre-mix any of your modifiers, all of our detectors, including our single and our ELSD. And of course, our Lotus GLS gas liquid separator design is second to none in both recovery and purity. Our software, all based on lab solutions, method scouting, method development, and preparative software are second to none. And we have lots of new and novel applications that are coming out, and these are increasing every day. So with that, I'd like to conclude the presentation portion of our webinar today. Again, I'd like to thank everybody for joining us. I know your time is very important. One of the goals I always have with a webinar is to provide all the listeners with at least one piece of information they can take back to their labs later that day that makes their life, their work a little bit easier. I hope I've done that. If not, we have additional information here, and if you have additional questions, we're always happy to help. Again, thank you very much and have a great day.
All right, let's thank Steve for such an exciting presentation. Again, under the resource list, you can find more information about our analytical solutions. If you've not had a chance, please fill out the survey questions on the right-hand side to provide feedback and request additional information. We also encourage you and your colleagues to attend our upcoming webinars, which encompass a wide variety of application areas. The registration link is located at the bottom of this slide. At this time, let's begin our Q&A session.
Hi, everyone. So sorry about that. We were having technical difficulties. So I have Steve Swartz with me right here. Steve, are you still on the line?
I'm still on the line.
Okay. Great. So there was apparently some silence from that first question. Do you mind just re-answering that question with SFC compared to HPLC?
Yeah, so again, the question was, does PLC, or does SFC, I should say, have the same sensitivity as HPLC? And the answer is no, not quite. We're very, very close. If you go back to, historically, go back to some of the earlier systems, one of the big knocks on SFC was that it did not have the sensitivity because of the pumping systems. There was a lot of signal to noise issues, and so unfortunately, a lot of people went to HPLC, and SFC became kind of an afterthought. But over the years, technology has advanced, and it's gotten quite a bit better. Is it quite at the level of, say, a UPLC system? No, but it's very close. And SFC does have an added benefit, as we showed earlier. When you put in line a mass spec, whether it be a single or a triple, post BPR, you do get an increased sensitivity signal on there. So the answer is close. No cigar yet, but we're getting better and better every day.
All right, great. And another question. I think this is going to be a quick one. What's the max number of columns that I can have on a multi-column system?
Well, that's a great question. We do advertise up to 24. There are some specialty systems that we do more, but typically 24 seems to be the top number.
Okay, nice. And a question from one of the audience members today. I've had issues with the Lotus separator spraying liquid through the ventilated bottle caps on the prep fraction bottles. It seems like the pressure is not near zero, such that the liquid would drip in a more controlled manner. Is there a way to reduce that pressure further before it gets to the fraction bottle and Lotus separator?
I believe there is. I don't have the software in front of me, so I can't specifically say where it is, but that should be adjustable, especially since you do have a makeup pump that is pushing in, so we may be able to reduce some of the flow rate on the makeup pump. That should also help.
All right, great. And we have another question in here. Does Shimadzu still plan to develop SFC going forward? And how might they go about that?
So we're probably one of the only companies out there that seems to be pushing SFC technology, and I think we've made a lot of great advancements. The company, Shimadzu, is dedicated to this technique, and I expect them to make additional advancements over the soon coming years and well beyond.
All right, good. And I'm not seeing any other questions that have been entered. So I guess we can end it on that note. Thank you so much all for asking your questions. It looks like we're at the end of our allocated time for the webinar. Since we don't have time to answer remaining questions, we will reach out individually to each of you whose questions we weren't able to answer today. Again, thank you all for attending and participating. Steve, thanks so much for your webinar today and for answering these questions with the Q&A.
Thank you, Kevin, and thanks for everybody joining us.
Yes, and again, we encourage you and your colleagues to attend our upcoming webinars, and the registration link is located at the bottom of this slide. Have a great day.